we had a good example. We have all had a good example of what climate change means in two ways, I think. So the first one that we all got a lesson in how climate change impacts our own planning and our own lives. And the other thing was that it was quite of an example in data-driven decision making around, in this case, extreme weather events. And I guess many of you have been tracking these events that happened around the hurricanes and whether the conference can actually happen or not, and so on and so on and so on. So in general, I think we all know that climate change has enormous consequences onto the planet and everything. And we are, as researchers, we're really interested in trying to see how we can help and support these topics. So on the other side, we think that we have been working a lot on awareness and understanding for data, for climate change, and so on and so on. If you have followed the discussion over the past years and decades, there was a lot of this discussing, and we think it's time to go beyond this awareness and understanding, and actually look into action and how we can help people mitigate climate change. How can we track what is happening to the climate itself, but also to our own actions? How can we empower people to do really the right decisions? And it doesn't really help that climate change is a wicked problem that doesn't have this one single solution, but instead we need all to kind of collaborate on these things. We need to make trade-offs, and eventually we need to understand the data and our impacts in a sense. So for us, the question really is, how can we deal with all this information, with this uncertainty and dynamics around climate change and climate action and building a sustainable future? So let me now hand over to my colleague Eleni, who will introduce the work that the NASA is doing in this regards.
So, hi everyone again. I'm from NASA Goddard, from the Scientific Visualization Studio. So to provide a little bit of context here for the work, NASA satellites have provided open source and publicly available data on Earth's land, water, temperature, weather, and climate for more than 50 years. And to improve access to this key information, NASA Administrator Bill Nelson announced publicly on October 2022 the concept for the Earth Information Center. And NASA's Earth Information Center initially was proposed as a mission control, but the goal was to allow users to see how the planet is changing and provide easy-to-use information and resources that support decision makers in developing the tools they need to mitigate, adapt, and respond to climate change. So given the Earth Information Center effort, we developed a workshop back in 2022 titled The Workshop on High Impact Techniques for Climate Science Communication, and executed that in an effort to bridge the gap between research and practice and identify directions for research, but also for practitioners to understand also where and what we should do better as a community in order to address one of the grand challenges in our era. Next slide, please. So Earth.gov has come to life. If you can play the video, Ben, has come to life. And the Earth Information Center, or you can find it on Earth.gov. It launched on June 2023 with a goal to consolidate data from 7 US federal agencies on how our planet is changing and bring to the hands of policymakers, state and local governments, and the general public data to prepare for climate change and environmental challenges across the country. So Earth.gov serves as the gateway to other interagency efforts, such as the U.S. Greenhouse Center and the U.S. Sea Level Change, which was announced just last month, end of the month, September 2024, and currently aims to address 9 themes: agriculture, air quality, greenhouse gases, biodiversity, disasters, sustainable energy, sea level rise, wildfires, and water resources. If we go to the next slide, please. So visualization is key to bring meaningful and impactful data to the hands of stakeholders and the public. And our group, the Scientific Visualization Studio, was tasked to lead the data this effort, represented in the installations, but also on the website and various initiatives. Here you can see a hyperpole system at NASA headquarters, and it has content that basically features over 100 data visualizations, multiple data dashboards with multiple stages, and narrated video pieces. So we build visual data stories around these themes using a three-legged approach: a narrated video piece followed by data dashboard, followed by an awe-inspiring data visualization. And all content is crafted in 8K resolution with the highest quality and detail possible. And we have developed interactives, web applications, and also we orchestrate the backend infrastructure for Earth.gov. Here you see the latest initiative that opened October 6th at the Smithsonian at the National Museum of Natural History. So I just wanted to provide an overview how we started in 2022. We had 6 months to bring the Earth Information Center on live, and we have brought to life 2 major exhibits right now, and we are moving forward. So we need to keep our efforts moving forward as well, and reach to the VIS community and try to bridge the gaps. Back to you, Ben.
Thank you, Eleni, for this demo. This is truly fantastic work, and it's a really nice example to understand the scale of data really that we have right now at our fingertips, and we just need to make use of it. Yes, so we have kind of understood that there is a role of visualization in making this data accessible to experts, to non-experts, to wide ranges of audiences. Eleni was just saying, mentioning policymakers. And again, this is why this project is a really nice example for the mission actually that we have as researchers and people actually. And we have seen lots of other visualization examples coming up over the years. So some of them you may be well familiar with. On the top ones, the hockey stick chart, the climate stripes, the energy scorings that are now on sort of buildings and any sort of appliances, but and as well as visualization atlases for sustainable development goals, for example, which try to unpack and show a lot of the data that is actually available around, in this case, climate change and so on and so on. But also kind of more niche or new ways, as you can see on the bottom row here, like data comics or immersive environments where people can understand the scale of their personal impact on their environment, and as well as physicalizations in the form of tokens or large scale room filling visualizations or physicalizations as in the top right. So we have a wide range of efforts, and so far they have not been coordinated, which is again another motivation for this workshop, that we have finally a forum where we can share all these examples and discuss what exactly is needed and what is specific about visualization for climate action and sustainability. And again, our focus really wants to be on this action part rather than just understand. So again, for this workshop, we have 2 main high-level questions. The one is, what can visualization and visualization research can do to support climate action? And what are the challenges that these action and these applications pose to the visualization research community? And how can we generalize what we find in this field? Because obviously there will be always findings that we want to generalize to other parts of visualization as well. So there's then, of course, a couple of more sub-questions, whether this is around how to visualize complex data for complex systems such as climate or the circular economy or biodiversity. How can we support individual decision-making through dashboards, through personal tracking, and so on and so on and so on? How can we reach diverse audiences? How can we track our impact onto the planet? And how can we communicate possible futures, for example, in the context of modeling and so on and so on? So lots of questions that are rooted sometimes in this very specific domain of climate action and sustainability, but also rooted into other areas, in other areas of visualizations, and where we hope there is a lot of cross-pollination eventually happening. So the goals of this workshop again are to collect research examples currently, what people are currently doing, then to discuss the potential for visualization in this area and understand the challenges and opportunities for visualization. So to kickstart the workshop, we had 4 submission formats over the course of the summer, and we were asking for full papers for publication in IEEE, this in the digital library. We had a call for short papers. We had a call for demos, interactive demos, and pictorials as well. We had in total of 19 submissions, of which we could accept 13 as full papers and short papers. And kind of fortunately or unfortunately, we don't have demos, so we would have loved to have these demos, of course, live in Florida, but hopefully we have them next year if we're going to run the workshop again. And we want to like to thank the International Program Committee here who reviewed all the submissions. Each submission was reviewed by 2 of the IPC members, as well as at least 1 of us conference workshop co-chairs. So the schedule of today's talk, today's workshop, we have about 3 hours. We're going to run the session until 11:30 Florida local time. We have 2 main sessions. There is a break in between of 15 minutes. And in the first session, or in each session, we have 2 topics. The first topic, which I will chair myself, is on storytelling and communication. And this topic has 3 talks. They will run back to back without any QA. But this will bring us through half of the time that we have dedicated to this first topic. And then we have, again, around 15 to 18 minutes for a general discussion on either the talks in this session or the topic of storytelling and communication in general. And this is, again, where one of the reasons that we switched to Zoom, because we want people to raise their hand, to speak up themselves. The questions that we want to discuss in these topics after the talks are really meant for everyone. Of course, we invite the presenters to stay on as sort of a mini panel, but the questions are really should be engaging, should kickstart a discussion in the audience. So and then once this topic 1 is done, we're going to move to the second topic without the major break in session 1, and then we have the coffee break, and then we do sort of the same thing in the afternoon with the other 2 topics. And eventually we have some time for an open discussion and closing remarks at the very end. The stage is yours, Fabian. Again, this first session is on storytelling, the topic of storytelling and communication. Thanks, Fabian. Stage is yours.
Thank you. Thanks for the introduction. I'm going to talk about local climate data stories. My name is Fabian, and I'm presenting here on behalf of my co-authors, Lukas and Mark also. So this is a discussion paper discussing how we can leverage data-driven storytelling to communicate effects and mitigation of climate change with a specific focus on the local context. So our scenario consists of climate change as a topic on the one side, but on the other hand, locality as a second thing. And this discerns us from a lot of data stories that are already there about climate change. They often report on global phenomena and abstract things, but not something people can see and experience in their direct local environment necessarily. And since we are having data stories, data is an important ingredient too. And on the other hand, we have the citizens of a city or region as our stakeholders who will consume those data stories. In the paper, we emphasize 7 different characteristics of the scenarios. So quickly going through it, we have certain topics of climate change with specific relevance for the exact local setting. So some cities might be at a river, have different features than those at the sea, and so on. So depending on the climate, local climate, different topics are relevant. Then, of course, the locality provides a very limited scope. On the one hand, this might be a challenge because data might not be available on the local level as on the global level. But on the other hand, also a great opportunity because we can maybe record some data ourselves, or we don't have to deal with huge data sets to do something to visualize it and present it. Then we can also consider the local context. Often you can only interpreting the data if you know the context it was recorded and refers to, and this is much easier in the local scenario, because there we can easily research and describe the local context. Maybe we don't even have to describe this explicitly, because people might be very familiar with their local context. So we are addressing the citizens of the very region or city. So they are, on the one hand, laymen regarding maybe climate change and data visualization, but they are experts about their local environment. They know where they live, and we can build on this previous knowledge and go much deeper than maybe if we have a general data story on the global level. This also connects to an increased interest and concern. If people are seeing their own environment affected by climate change, they might be much more interested in the topic, and maybe we can reach audiences broader than we can typically reach with data stories if we report them in a global context. Also, the local context gives options for participation. So the citizens might not be only the consumer of the data stories, but also can take part in the production of them. So either individual citizens or through interest groups and institutions, they can participate in collecting the data, analyzing the data, describing the data and the insights. And of course, like Ben also mentioned in the introduction, we are interested in presenting some actionable conclusions to do something to mitigate climate change, or to change something. And here specifically on the local level, it might be much easier to do something than on the global level. So the hope is that people might not, after reading such a story, be frustrated and depressed, but feel rather inspired to do something in their local environment. In the paper, we have more content. We analyzed a few data stories from local journalism. We found some interesting ones and that reported weather data and related things. But what we didn't find is a lot of visualization. So data was mainly described textually and not as visualization or even interactive visualization. Then in the paper, we have featured 3 examples of interactive stories as examples for local data, climate data stories that students developed at our university. And there we have 2 scroll stories and 1 interactive animation that discuss different phenomena like local heat islands, the local vegetation, and a local outlook on the next decades, how many heat waves we can expect and things like that. We added also an educational perspective. So what was our experience using these data stories in an educational context, and give some insights on that. So finally, we are discussing research challenge and opportunities that we want to address in the future, and hope maybe to inspire also some work of others, and are open for collaboration. We want to look into better authoring support and adaptive stories. So we think that often on the local level, people have problems developing great data stories because it's quite resource intensive. And by making the authoring process smoother, we can help in this regard. The local context also provides great opportunities for disseminations. For instance, we can think about on-site stories that show the data in the context they were actually recorded, and make them really tangible in the local context. But talking about the topic like climate change, it's also an emotional topic of high social relevance. So we might need interdisciplinary research that studies the impact of such data stories on emotion, on social and political debates, as well as ethical aspects. So this is was a short walk through our paper on local climate data stories. In the center, we have these 7 characteristics, and further contributions arranged around that. Thank you.
Thank you, Fabian. Please put your questions in Slido or keep them for yourselves and raise your hand. We have our next speaker, Sejong Wang from Simon Fraser University. Welcome, Sejong. And those will be 2 short talks about 2 short papers. We cannot hear you yet.
Right.
There you are.
Okay. Hi, everyone. My name is Sejong Wang, a postdoc from Simon Fraser University. In this project, I collaborated with experts from climate science and literature to create data comics for explaining the science and data about climate change. Today, I'll be sharing 2 examples. First, it's titled as Pasta or Disaster on the topic of permafrost. And the second draft work in progress is titled Blooms on the topic of eutrophication in freshwater. So to create these comics, I use fiction, combine the explanation of scientific concept with the expressive data visualizations. Fiction means we combine the factual information with the storytelling techniques. For example, during hiking, a family discovered that a mountain hut had been demolished due to the thawing permafrost. And then they started to discuss the status of permafrost, such as the geographical distributions, temperature change of permafrost at a global scale. By looking at the temperature, there is a common misconception of permafrost near 0 degrees are not thawing. That's due to the physics of latent heat. It's similar to when boil water starting from snow. The temperature stay at 0 degrees until the very last piece of ice melts. They compared this experiment to the temperature changes observed in permafrost. The second example highlights the increasing ecosystem problems in freshwater due to the proliferation of blue-green algae. And since animals are directly impacted by the lake eutrophication, and they are motivated to uncover the problems affecting their lakes and playing roles in data collection and analysis using their unique abilities. For instance, the heron observes from the sky and creates an abstract art and representing the chlorophyll concentrations, which is based on actual satellite data. And underwater animals from different locations and contribute to water sampling as a part of citizen science initiative. A snail analyzes the water samples to estimate the biomass of algae and presenting the process of counting and estimation methods. And the result of water sample analysis are presented through a data visualization that's created by different types of water plants, representing the biomass of various algae types. And now we are making more examples. I would like to connect any of you if you're interested to discuss this work further. Thank you.
Thank you, Sejong. And we have our last talk from Katrina. Welcome, Katrina.
Hello, everyone. I am Katerina Patriakouvi from India, France. And today I'll be presenting our position statement paper, which discusses some challenges of designing visualizations to enhance the carbon numeracy of the general public. Studies have shown that people are increasingly aware of high emission actions like flying or eating meat and are able to make qualitative comparisons, such as recognizing that an apple has lower emissions than a burger. However, we struggle to understand the differences in magnitude between individual actions, underestimating or overestimating the impact of our choices. The ability to quantitatively understand the emissions associated with everyday choices, defined as carbon numeracy, and is crucial for reducing our individual carbon footprints and achieving the goals set by the Paris Agreement. Different daily actions have varying carbon costs, from some grams to tons of CO2 emissions. Common visualization techniques, such as linear and logarithmic charts, are not effective to support quantitative tasks between several orders of magnitude. Linear scales make it impossible to read and compare smaller magnitudes, and logarithmic scales present challenges for quantitative tasks, like estimating differences or ratios between values of same and neighboring magnitudes. As members of the visualization community, the challenge we face lies in designing novel visualizations of carbon emissions that effectively represent the magnitudes of different actions, facilitate quantitative comparisons, and help people assess the impact of each action. To address these challenges, we propose some visualization features that could address these issues. We can leverage insights from cognitive psychology about human interpretation of large values, such as the categorical encoding of weight units, mimicking the way that we talk about numbers. We can also use scales proposed from the visualization literature about large value ranges, or design and evaluate novel ones. And last, we can incorporate defined metrics or thresholds, such as the daily and annual thresholds of CO2 emissions based on the Paris Agreement, to help people assess the impact of their actions relative to those metrics. In the example of the visualization we designed, we can see all the magnitudes and quantitatively compare. For example, a transatlantic flight costs almost 100 times more than a train ticket from Paris to London. A burger costs almost the half of our daily threshold, and a new car can be equal to 10 years of emissions. Controlled experiments will be necessary to evaluate the effectiveness of these visualizations for both low-level and high-level tasks. Thank you for your attention.
Thank you, Katrina. Thanks to all the speakers again, so big round of applause in this virtual room with all the virtual echoes. We have now time for questions. We have about 10 minutes, less than 10 minutes for questions and high-level discussions. Again, put questions in Slido. Do we have any question right now in the room? Please raise your hand. I see lots of applauses. I have a first question I want to start with, and this is, again, any of the presenters, feel free to start answering this, but it's really, I think, a question to everyone. Oh, we have a question from the audience? No? Okay, so my first question would really be, from all your techniques, from all the research you have described and from your own experiences, how do you think we can best turn understanding into action through storytelling and data? So going beyond the communication and understanding issue, but how can we make people, say, play with the data, interact with the data, experience this, how this stuff is relevant for themselves, and empower them to do something with the knowledge that we want to transmit through these stories? Just raise your hand if anyone wants to speak.
So maybe I can comment from this more journalistic perspective that journalists try to do that in their articles to present conclusions also, but it's sometimes hard to always give some positive outlooks. It's specifically hard if it's a global problem and you're at best can have something on the local level. So localization, that's what we're suggesting for making it easier. But first, to make this effort. And maybe another thing is there are many great visualizations, and we've seen some here also on how to visualize personal impact. But I think this approach of the personal footprint is quite limited, because you can only improve your own personal footprint. I mean, you can set an example and hopefully other will follow, but it would be more effective to change something on the political level so that people push, I don't know, their representatives in doing something, and that this topic becomes important in elections, although maybe some other topics seem very relevant at the moment too, and stuff like this. So I think the political dimension is very important if you want to do something about it.
So are you suggesting we're just powerless as visualization people and researchers?
No. But our visualization should get involved with politics and decision making, and maybe it's nice to analyze their own footprint, but the impact beyond that is much more interesting if we really talk about changing something.
Penny?
There is a question from the audience for Jizong. Sorry if I missed it. Was there a target age for each comic you made? Did it influence the style you chose?
Right. So since when we do that, we aim just the general publics who have no experience working with this data or never heard about those concepts like permafrost. So when I designed it, I didn't have a very particularly group of age, but just a particular background of like visualization or data literacy, which is the beginner. But when how it is perceived, so after they seen these examples and they were very interested in the permafrost one, and then they decided to include this in their national mountain report, but a session under for children. So I will see how it's being perceived by children, but I think I definitely see it's easier to be to be understood for children because the level of the knowledge and the complexity of data is not very high. But we don't know. We haven't tested with different groups.
This is actually a follow-up question. So I've really liked hearing about the data comics, and I would be curious to learn more about how the students received it. So we did a multimedia storytelling project about ocean life this summer, and some of the students really loved it. These are college level students, grad school. And some of them felt like it was too far removed from action. And so I just wonder if you experienced that too, and if so, how you navigated that.
So can you repeat that? So then experience what? I missed that.
The using using multimedia storytelling
Yeah.
to really get into both the data and the research, but also to express themselves very creatively.
Mm.
And some of them really enjoyed that, and some of them didn't. And so I just wonder if you experienced that too, and if so, how you navigated it educationally.
Right. So you mean they enjoyed it while they creating that, right? During the creation process.
Yeah.
Right. Yeah. So yes. So to make that, I need to understand the data myself. So I need to really understand what is going on there, understand the science behind it, and that does like encourage me to go deeper, to understand the science. And because this project is collaborated with climate science, I had the privilege to closely work with the scientists who actually doing the field work, who collect data in the field, who analyze the data from different resources. And I heard their stories, like either how they did the research or personal anecdote around the challenges. So which is very fascinating. And now we are trying to use the similar methods, but not me creating the data comics, but the others. So for example, we involved in some indigenous people who can tell the story from their perspective. So there's a whole different new perspectives. And yeah, I do believe so. While during this collaboration between different people from different expertise and backgrounds, so they exchange knowledge and learn new stuff, and they also have new insight during this collaboration process.
Thank you.
Thank you, everyone. If you ask a question, please state your full name and affiliation so people can follow up easier after that one. We have one very quick question from Slido, which is from a post by Elsie Lee Robbins. How do you evaluate whether and to what extent your visualizations are effective? If anyone wants to reply?
Maybe, yeah, Katharina.
Yeah, I think it really depends. So if, for example, in our case that we focus on quantitative comparisons, it's important to check if people, they can actually make these comparisons. So we measure time and accuracy. But in cases that we care about engagement or understanding, I think other approaches have to be more suitable. I'm not aware about how to evaluate engagement, for example.
Fabian, maybe a quick comment before
Yeah,
we
maybe
move on to the next topic.
further than this. So if people really do something differently later on, but this is hard to evaluate because we would need long-term studies, and maybe it's not this one thing that changed their mind, but multiple things that contributed. But that would be probably the ultimate goal here, but really hard to measure.
Okay, thank you all the speakers again and those who engaged in the discussion. That's the end of the first topic, and I will hand over to Fanny to introduce our second topic. Thanks again, everyone.
So for the second session, the topic is going to be immersive and tangible. It's going to be 3 presentations, 2 long papers and 1 short papers. So our first speaker is Dushani Pereira, who is going to talk about Eco Garden. Dushani, over to you.
All right, so I'm Dushani Pereira. I'm a PhD student at Cardiff University. So I'll talk about the data physicalization that we created, which is called Eco Garden, which is right behind me over here, that visualizes household consumption data. So to give a bit of context, households engage in daily practices such as watching TV, doing dishes, or doing laundry. But nearly 2/3 of global emissions are linked to such carbon-based such activities that households conduct, according to carbon-based accounting. However, people in households are not aware of how their actions can actually contribute to climate change. So to address this, we conducted a research to develop a data physicalization, particularly a data sculpture, to visualize household consumption data. So we did this research in 4 phases. I'll briefly go through the 4 phases. More details are in the paper. So we took a human-centered design approach here. So in phase 1, we explored household consumption practices, what challenges they face, and how they would like to visualize data. In phase 2, we conducted workshops to explore the design space. And in phase 3, we did the first version of the sculpture. And then finally, in phase 4, we did the final version of the sculpture. So in phase 1, we used 4 low-fidelity paper prototypes to conduct a survey study and 13 household workshops to understand people's challenges and how they would visualize data. And here we found certain design considerations, such as the physical artifact should be interpretable, it should be aesthetically pleasing, everybody in the house, including children, should be able to engage with it, etc. Based on these design considerations, we then created 5 low to medium fidelity prototypes and then conducted 15 household design workshops to collaboratively come up with a concept, a design for a data physicalization. So based on the findings we got here related to familiarity of objects, the personal connection people make with the objects, etc., we then created the first version of the sculpture. So it's got 3 discs, each for electricity, gas, and food waste. This selection also came from participants. So on each disc, there's a flower, as you can see over here. And on each flower, on one petal, there's a bee. So this functions as a traditional wall clock. The bee starts at 12 o'clock position in each disc and then rotates clockwise gradually throughout a week from Monday to Sunday to show the household consumption. And around each disc, there are these tiny flowers which are connected to an addressable LED. We did a complementary mobile app on which people can set a weekly target for the consumption category, and that the LED corresponding to that value will be lit throughout the week. So the idea is not to let this bee rotate beyond this target value within the week. So then with these two first versions, we conducted 14 user feedback workshops. And then with the feedback that we got from the participants, we then modified the sculpture to the final version where the size is smaller and then the discs are color coded by blue, yellow, and green. The colors are reflected on the app as well. The participants are able to choose the colors that they want for the discs, and also they can choose the colors they want for the LEDs. So there's some sort of adaptability there. And also the UI of the app is also modified according to the feedback. And then we conducted 15 household, we conducted a field study with 15 households where each house used the system for 3 weeks. So we did this from February to July this year. So on the paper, we report on the preliminary findings of this study. So we found that EcoGarden helped people to understand their consumption and reflect on how their activities can contribute to carbon emission. And also it motivated practice changes in the home to be more sustainable. The main takeaway from this research is that there's a need to engage individuals and also households in an important topic such as climate change. EcoGarden is just one approach to design for sustainability, but it is an example of how physical manifestation allows adults and also children to contextualize sustainability in their personal life and collaboratively work towards environmentally friendly practices. Thank you very much.
Thank you so much, Deshani. Please save your questions for after the 3 talks are over. We have a slight change in the schedule. Nina is going to go first, and then we will hear from Rachel. Nina?
Yes, thank you so much. I'm going to share my screen. Let's see. Can you guys see my presentation?
We can.
Okay, great. So hello, everyone. My name is Nina Rosa. I'm a postdoc at Wageningen University in Research. And together with students from Utrecht University, we created an augmented reality app called Aware. And the paper I'm going to discuss is using handheld augmented reality for researching the potential of food resource information visualization. Well, I don't need to talk about climate change too much, but in the prospect of consumer behavior, there's still a huge attitude behavior gap. Which is mostly a result of barriers that are experienced. One barrier in particular is psychological distance, so feeling that the problem and the consequences are very distant. This is spatially, temporally, hypothetically, and socially. And one example is from the food industry. We've kind of created food systems in such a way that psychological distance was bound to happen. We no longer really see our food being grown. We don't see it being processed or transported. And in this regard, virtual reality and augmented reality have been suggested as very good communication media that could help in, for example, learning, but also creating awareness, creating interest, and also changing behavior. So in this regard, I'd like to show 2 studies in augmented reality and virtual reality. So this study was by colleagues of mine using augmented reality to understand the amount of food waste that is created in Dutch canteens. So this project was very data-driven to understand food waste on the one hand, but rather than creating this large Excel sheet that tells us X amount of breads were wasted, actually show the foods themselves to create a better understanding of what solutions could be used to solve this food waste. So that's in the now. And then looking at more future thinking, this study by I+II+III and colleagues used virtual reality to let users create a meal. And then based on their selection in this meal, we could see the future of the Rocky Mountains 30 years from now. So using a more plant-based meal tends to show a very nice Rocky Mountain landscape, where a very high meat-centered meal shows the degradation of these Rocky Mountains. So using the potential of these, of especially augmented reality in this regard, we decided to create an application that could be used to tackle hopefully many of the problems that the literature is now showing in this area. Our application is called Aware. It's a smartphone application, and the aim was to let the user input a list of real foods or ingredients and then visualize the resources required to produce the food on their smartphone in their own kitchen. So what this means is that when the user opens the app, they have to scan their kitchen. And this just means the depth sensing on the phone, and they have to select surfaces on which they can visualize things. And then we see here an example of the app in use. This is in my own kitchen. So here I have an example of a meat-centered meal where, a very simplified meal with pork and beets. So you see on the right-hand side, the pig that is used for the pork. We see near the center, the wheat plants that represent the feed that is required for the pig, and then the beets there next to the wheat plants. And then in the middle, we see the water that is required for all of these elements. So for the animals, the feed, and for the crops. And then in contrast, I have here a completely plant-based meal, which I call salad. It's an unusual salad, but it includes a bunch of different plants that can be shown in my kitchen. And then we see the smaller water requirements for all of these crops. So like I said, the idea of this application was to use it for future research directions, and I have a couple listed in the paper. I've categorized them, the first being experiences. So what we really want to understand is how the features of this implementation currently relate to the barriers that are experienced, in particular psychological distance. The reason we ask people to use this application in their kitchen is because it really connects the concept of food and their own actions together. And then the next step would be to perform a comparative study using AR in and out of a kitchen, but also augmented reality versus virtual reality, for example, or even a desktop version. With interventions, that would be the next step. So going beyond the barriers of, for example, psychological distance, we really want to study the effects on awareness, but also, for example, connectedness with nature, and also, of course, behavior change, because that's why we're here. And then next, interactions. So right now, the experience is quite passive. I mean, besides having to input food that you might actually be using, there's no interaction between real and virtual. And we want to encourage people to interact with the virtual food, but also make connections with the real environment. So maybe they have to harvest their own crops, wash them in the sink, for example, and see whether these interactions actually amplify the effects that we saw in the interventions. And then lastly, there are some methodological aims. So in research, we're really seeing that we're lacking these longitudinal studies. The app is designed to be used in the home rather than in a lab, and we hope to facilitate these types of studies. But also we're looking into collaborating with online supermarkets to gain real data. So rather than gathering data on intentions, we measure more realistic behavior. That was it. Thank you. If you want to send me an email to ask more questions about that, there it is. And this project is also listed on GitHub for you to further develop and also download the application yourself. Thank you.
Thank you very much, Nina, for an inspiring talk. We have one last talk for this topic. Eleni is going to share the slides for Rachel. And Rachel, you can take over whenever you're ready.
Hi, yeah, good morning. My name is Rachel Connolly. I'm a research scientist at MIT in the Media Lab, and I work in the Future Worlds Research Initiative, and I'm here to talk about the Earth Mission Control platform that we've been working on developing. So next slide, please. Earth Mission Control recognizes that so much of our Earth observation data and climate variables are really measurable from space, but bringing together and knitting together all these various modalities of data can be very difficult. Next slide, please. Our goal is to really bring the data and the insights into some collaborative conversations and ultimately to action and decision-making. And so we adopt a framework of going local, hyper-local to where you are, global to understand the bigger picture concept, and back to local for the decision-making. So knitting the cohesive experience together with the data is really, this is our goal. So next slide, please. And could you hit the button one more time? So Thank you. These are 2 videos of 2 case studies that we have developed so far, one on sea level rise and one on wildfires. And you'll notice that you're in an immersive experience where the actual climate impacts themselves are dynamic and motivating and affective in nature, but that then the different formats and modalities of data can be put together into one single environment. If you can go to the next slide, please. We have dashboards that allow you to control and bring up different kinds of data in the flat screen and interactive forms. We have a map table that allows us to go hyperlocal to particular places through different 3D models and maps. We have a globe that allows us to project spherical data sets. And then we have the dynamic scenic environment that it's all embedded in that sort of knits together the narrative. If you could go to the next slide, please. We also have a sandbox version of it. What we just showed was a more produced version that we do for demos, but this is the sort of student sandbox version where we can have multi-users get together around the table, go in real time to specific places, as well as work remotely with other scientists to, say, bring up particular data that they have to share right then and there. So we're really working on driving these conversations in real time for better collaboration and design. So if you could go to the next step, please. We've done user testing. Our 3 primary audiences are educators, and we do include the public in that in terms of their level of expertise, policymakers, and industry. We've done user testing that's really helped us understand the emotional response to the data, and the immersivity was really important, actually more forefront than background, we realized. The hyper-local climate data was really critical to, it's one of the things we're really working on, particularly through AI tools to help improve that hyper-local on-the-ground conversation. And then the interoperability and democratization of the data is the other thing that's been really critical to work on. So thank you for your time. Please feel free to connect. It is available at open source and on GitHub. If you'd like, please feel free to reach out and I can get you to it.
Thank you very much, Rachel. Thank you again to our speakers for this topic. Please, as per usual, raise your hand if you have any questions, want to make comments. You're all way too well behaved so far. We want a little bit more discussion, interaction. Don't be shy. We're happy to have these interactive discussions. I'm going to leave a little bit of an awkward silence for everybody to speak.
I have a question, but my raise hand doesn't work. So
perfect. Take over, Bess. Take over.
Oh, really very interesting work. And I was curious about, you said the emotional testing, which is always a challenge. And so I'm wondering if you can talk a little bit about, I look a lot at what are the emotional barriers that we raise to prevent ourselves from diving into topics. And so I was interested in your emotional testing, and if you could talk a little more about that and the results and how it impacts where you're going with the work.
Sure. I appreciate it. It's a really good question. I would say that initially when we started designing, we were really focused on, the different modalities of data with the map table and the, that type of thing. And we just wanted to have it embedded in a really contextual environment that was dynamic, that was consistent, with the different impacts that we were going to be telling the story about. So when we started to test it, though, with the different audiences, the first things they were saying is, whoa, the waters, like the fact that they were experiencing these impacts themselves, watching the fire come and impinge on the neighborhood, and that actually became that sort of initial and most important element to them. And in some cases, they were like, this is really intense. Now I want to know, like, it actually drove this, like, I want to know more about what this will mean for where I am, because then you go into a local place where it says, this is what wildfires have been increasing in this location, or sea level rise can be this in the next 5, 10, 15 years. So it actually helped drive that desire to almost want to know, what does this mean for where I live? And that urgency, and in some cases, some audiences, like younger audiences, were a little like the sound. We had to be careful with sensory overload for some audiences. So I would say that what it means is we're really going to be expanding our sort of library of what these impacts might really be like to experience in a realistic way, and marrying it with the kind of data that sort of backs up the what could look like in the future. So anyway, I hope that helps. It shifted from a background to a more forefront element of our design, if that makes sense.
Wow, we have all of a sudden plenty of hands up. I want to be mindful of time, but we're very happy to have the discussions going. Jessica, go ahead.
Yeah, I had a question along the same veins for Rachel. Did you find any overall differences between the three audiences in terms of their willingness to participate in the VR and then their overall takeaways and experience in VR?
Great question. Willingness, not so much. I mean, they were really interested in the experience, but their takeaways were really different and their focus was different. With industry, a lot of it has sometimes a lot of the industries, BP, Castrol, we work with large global entities often. And they're still interested often in bigger picture regional. They're not necessarily going to a particular location. They're looking at larger systems and like their supply chain, how robust their supply chain is, things like that. So they have a different, more systemic view of things they're looking at, but through slices of things like how will my real estate investments be, and things like that. So you have to do it more across sort of a construct or dimension, not necessarily a location. Whereas policymakers often are very specific to like, what does this mean for my community or my district or my city? And so they need hyper-local, but also more socioeconomic or types of data that really the interoperability of the data there is critical. So I would say that they're all really excited to explore it, but their narrative and what they need for their conversations are very different. So sometimes it's forefronting that hyper-local design, and sometimes it's having more of a regional or bigger picture view, but for a key area of something they're working in. Does that make sense? I hope that helps.
Yeah, thank you.
Great.
What do you think the benefits are to go beyond the desktop? So in the case of physical visualization or immersive visualizations, what are the big pros of trying to go with these media compared to the more traditional desktop or mobile apps?
Thank you for the question, Fanny. So I think when it comes to screen-based visualizations, it's been there for ages now, and we don't spend much time on we spend too much time on the screens, which has made us kind of distance ourselves from, for example, maybe the apps that are provided by our energy providers. For example, that's what my participants said, that they don't really look at the apps. The charts are there, they show, okay, you spent £5 today, £10 today, but it doesn't really make any sense to me. So when it comes to physical visualizations, physical artifacts, they approach the user in more senses, where the screen-based visualization is just a visual, where the physical artifact would give you the touch. It could be auditory, it could be sound, it could be smell. So you can create a more sort of a personal attachment with it. And the other thing is, when it comes to a screen, you have to put in the effort of going into the screen, looking, like scrolling through the data, clicking buttons, looking at the data. So you have to like diverge your attention from whatever you're doing to going into the screen and looking and understanding your data. But when it comes to a physical artifact, it can just sit on your, maybe the kitchen, pantry top, or your desk. It can just be there in the periphery of your attention and it wouldn't really bother you. But when you want to know your data, you can just look at it. And if you don't really want any distraction, you can just not have sound, not have lights. It can be just a movement, a shape-changing interface which gives you your visualization of data. So I think that is more closer to the people, and it can be less distracting, so it can be a good way of communicating the data.
Thanks to Shani. Unfortunately, Nina had to go, so she cannot take the questions, but maybe we want to hear from Rachel on the benefits of beyond the desktop from your perspective.
That's a great question. I think for us, it's really creating the gathering around and the opportunity for co-creation and collaboration where the data is available and accessible, but not overwhelming. It's really how to better integrate a data-driven and informed decision-making and planning conversation that literally is more available to a wider variety of ages, audiences. That's why we're very careful about the data that we bring in. We've had a great partnership with NASA's Science Visualization Studio that makes beautiful, accessible imagery and visualizations. So the curating and the design and accessibility is really what's key. And just bringing them around the table, literally, is the goal. And we do have a version of it that is desktop accessible. You do not need to be in a headset to join it. And so that's really what it is, trying to bring people together and around the table. I hope that helps.
Thank you, Rachel.
Sure.
Please, the audience, if you have answers also to these questions, more general questions that we ask, feel free to partake in the discussion. We still have a little less than 10 minutes for discussion, so I invite more comments and participation. Eleni?
Fanny, we have a few questions from Slido.
Yes, please.
So one question is from Anna Offenwanger. Echo Garden, how is the data collected for the visualization?
All right. So for EcoGarden, we've got electricity data, gas data, and food waste data. So for electricity, we used TP-Link TAPO P110 smart plugs. So we asked our participants to pick the top 10 devices that they use on a regular basis at home and use the smart plugs to collect the electricity data of those appliances. And that I collected through a relay system that I have inside EcoGarden, which is a Raspberry Pi based relay system. So that sends the data to my backend. For food waste and gas, the mobile app that we created, on that people have to enter themselves. They have to report their food waste and also self-report their gas data as well. For gas, of course, in the UK, it's very difficult to tap into an automated gas reporting system. I couldn't really find one. For food waste, I was initially trying to have maybe a weight sensor or something in the food bin, but I couldn't really go through with it. So both of those are in the app. I think it answers the question, Anna.
I think so. She's sitting right beside me. Bridger, please. Go ahead.
Yes, great. Hi, Bridger Herman, Carleton College in Minnesota. So I have a question for all of our speakers, actually. So I'm really interested. So like having done work in virtual reality and physicalization and all of this, there's a lot of work that goes into building these individual applications, right? So I'm curious to all of your takes on ways that we might scale these solutions up to being used in broader audiences and all of that. So particularly on the physical side and also on the virtual side.
I think I can have a go. So yeah, that's actually a very good question. So taking the prototype to the production stage, I think that's what you're So that's something that I was thinking as well. So for example, once we built this, it didn't take long. I think it took like a week or so, but all the laser cutting and even getting the materials and how sustainable are the materials. Like we tried to go for wood as much as possible, but then the inside, there are 3 layers. There are 2 layers which are acrylic. So the sustainability of the materials and how are we going to scale this was actually a problem. So how we thought of approaching it, we haven't done that yet, but our plan is to kind of have a concise circuit where, I mean, currently I'm using 3 microcontrollers inside this and a Raspberry Pi. That's not the best circuit, to be honest, but I reckon I can just do all of that with just the one Raspberry Pi. And also thinking about the cost of it, just recently there was this workshop. I wonder if you come across prototype to production, device prototyping to production sort of a workshop where they extensively spoke about this. So yeah, I mean, going forward, our plan is to think about the sustainability of the physicalization as well as mass producing them in a smaller scale with using the minimum number of circuits that I could use to just visualize the data that I want in the way that people would expect. I wonder if that answered the question.
Yeah, certainly on the physical end. I'm curious, Rachel, if you could speak to the virtual end of things, like developing assets for all of these different simulations. Certainly must take a lot of time, does take a lot of time, and like how that might scale to broader applications.
Yeah, I have two quick answers, but then it's a bigger important conversation. So thanks for bringing it up. In the experience of EMC itself, or Earth Mission Control, one of the things that we're working on is advancing sort of how the hyper-local data can be identified and responsive in through more AI tools. I mean, we know that that's going to be really critical to help get people ultimately towards, right now we still work on developing case studies for a place, but getting in and saying, let's go to a place in real time, that sort of like more responsive experience, we're going to be working towards and using AI tools. Another thing beyond Earth Mission Control is that we have other tools in our sort of toolkit. One of them is called Climate Pocket, which is it's a phone app development that allows you to see, physics informed future views of, in one case, flooding in particular areas. So how to have something that's more immediate and very specific in narrative on your phone, so it doesn't have to just be in the VR experience. So I'd say those are the two answers, how to make the virtual reality one more responsive right there, immediate through AI tools, and then how to make other tools that can be beyond the VR experience for looking at the future in a trusted way. Sorry, Mark?
Okay, thanks.
Mark,
Yeah.
I'm going to let Mark do this too.
Just some thoughts on scaling up the sort of VR experience. And honestly, I think one of the reasons we haven't done as much work in the VR space is precisely that, is that it tends to be the kind of solitary experience. One thing we did with the Earth Information Center that Eleni was talking about initially is we have an immersive room. So this is a way to create a group experience inside of sort of a 360 environment. They're still kind of small, the number of people we can get in there. We're building bigger ones. But one thing I'd advocate for if you're developing VR type applications is look at planetariums. These are like built-in immersive spaces where you can sit a couple hundred people and maybe not do everything you can do in VR, but bring a lot of the experience there.
I think Nagas had a question earlier.
Sure. So this is a question for Rachel. It seems that you're working with a massive amount of global data. My question is, do you have a way to dynamically update this data, or is it bound to a specific time frame?
Great question. The answer is it depends a little bit on the data. We do have through APIs the ability to plug into, air quality, some data that you can show on the dashboards in near real time, or as it comes in, that you can pull it down. But it is a little bit dependent on the data or the amount of contextualization and scaffolding needed to understand the data. Given that you have to sort of make sure you're integrating it sort of seamlessly into the experience overall. But that's a great question. So yes, you can with some data.
All right, folks, thank you so very much. We're reaching the time for the little break.
Issues of analytics and transparency are especially important. They're always important in data visualization, but in climate, they're extra important. So very excited to hear these 3 short talks we have, but hopefully we can have a really good conversation around this issue and how we can help build trust around our work. So let's start it off with our first talk on interactive visualization of ensemble data assimilation forecast for freshwater floods by Amaya Patel.
So yeah, good morning, good afternoon, good evening. I'm Amaya Patil. I'm pursuing my PhD in computer science at the University of Washington. And in this talk, I'll be talking about HydroVis, which is our interactive visualization dashboard for ensemble data assimilation forecasts of freshwater floods. So I hope by now we all know why forecasting floods is important. Florida has been going through a lot in the last 2 weeks itself. So that's the motivation basically. I'll jump directly into ensemble data assimilation forecasts. So on a very high level, this is what it means. We have an ensemble or a set of models. In this case, we have the weather research forecasting, hydrology forecasting model, which makes a forecast for the event of choice. In this case, they're forecasting the stream flow, that is the amount of water flowing per unit time in the river system. And because forecasts are not 100% accurate, we also gather real life observations, measure the amount of water flowing per unit time actually in the stream, in the rivers. And we assimilate or combine these 2 different sources of information to get a more refined estimate, also known as analysis. And in this way, we keep repeating this cycle again and again. And this process is not easy to understand or try in general. So what we did was we designed HydroVis. It's a decision support system, basically to visually understand flood forecasts and try flood forecasting models. So what we have here is a screenshot of the river system of Florida during Hurricane Ian in 2022. So we have a map visualization here, which shows the forecast for the stream flow, amount of water flowing per unit time in the geographical context, of course. And it also provides an interface to select 2 segments of choice to view the forecast in more details in the plots below. So the first plot in the bottom left corner here shows the forecast for the stream flow, averaged across all the models in the ensemble, or the river segment chosen from the map visualization. And we also have the option to toggle observation gauge locations, where we can actually gather real life observations, which are shown as red circles in the map here. And we can view those real life observations against the forecast in the plot here. So we have the red marks here, which shows the actual observations. Then we also have a histogram here in the far right corner, which shows the distribution of the outputs of the individual models in the ensemble. This can help weather scientists to try or optimize the model for a specific distribution, and can also help them understand how far from the initialization values have the individual models diverged over time. We also have inflation uncertainty being visualized here. Is basically an artificially applied uncertainty to prevent the system from collapsing to predicting a single value with false confidence. We have that over here. And then there are UI controls. We can change the kind of aggregation we are applying to the visualizations. We have mean, we have standard deviation, and we can also inspect the values of the individual models in the ensemble. Then we have the option to configure the visualization to show different data assimilation phase, forecast, analysis, which is the refined forecast, and the increment, which is difference between the 2 phases. And also show different inflation values in the dashboard. And finally, we have a time slider to view the forecast at any specific timestamp of choice. That is a very high level overview of HydroVis. I invite you all to watch the walkthrough video and also go through the short paper on the website. Thank you so much.
Thank you, Amaya. Our next speaker will be Carolina Veiga, Urban Computing for Climate and Environmental Justice. Take it away.
I'll be presenting for Carolina.
Okay.
Right. So, hi everyone. My name is Fabio Miranda. I'm an assistant professor in the Department of Computer Science at UIC. And our paper provides a brief overview of a set of projects that are grounded on the concept of urban computing, which was first formalized back in 2014 in a paper by Zhang and others. And at the core of urban computing is the growth in the availability of data about cities, from sensor data to weather forecasts, and more recently, image data on the built environment. And over the past decade, our team has been proposing tools and methods to analyze this wealth of data to tackle pressing urban problems, from the availability of sunlight access to how weather conditions impact older adults. And particularly in the past 5 years, we have been engaged in a series of research initiatives in both Chicago in the US and Niterói in Brazil. Two cities that are notorious for suffering from climate and environmental justice issues, including heat waves, flooding, landslides, and air pollution. And these interdisciplinary projects have brought together key stakeholders, including visualization and sensing experts, as well as city officials, civil engineers, public health experts, urban planners, and climate scientists, and more importantly, communities. In these collaborations, we have built a series of visual analytics tools for both experts and communities to interact and analyze urban data at scale. Though I don't have time to detail these tools, their references are available in our workshop paper. These tools have been featured in different media outlets and have been used for engagement activities by community residents, both in Brazil, but also in the US. More importantly, these tools and computational frameworks that we have proposed have allowed us to support the collaboration between scientists, communities, and policymakers. Communities and policymakers interacting to increase legitimacy of policy change, scientists and policymakers interacting to support evidence-based policy inputs, and scientists and communities interacting to ground innovative research on actual real-world needs. Despite all of that, however, building these urban computing pipelines that straddle data collection, generation, all the way to visualization, while accounting for the specificities of different scientific domains, is still a challenging task with many unaddressed issues that we highlighted in our paper. Perhaps more importantly is the fact that solutions are still being built in isolation, which leads to the wasted effort trying to replicate or implement methods and tools. To solve some of these challenges, we have been recently awarded by NSF to build Oscar, an open source infrastructure for urban computing. In the near future, we will integrate some of the methods and tools for the exploration of urban data, addressing challenges from data discovery to the visualization and reproducibility, making them available to a broader audience. That's it. Thank you.
Thank you very much, Fabio. And then the final speaker in this session will be Yu Ying, exploring the reproducibility of visualization figures in climate change report.
Hey, can you see my screen?
Yes.
Okay. Hi, everyone. I'm Lu from Zhejiang University, and today I'll present the paper exploring the reproducibility for visualization figures in climate change reports. IPCC is the intergovernmental panel.
Sorry, I think we're having an issue. It seems overly zoomed in. Is everyone seeing that?
Sorry?
Like I'm
What's
just
wrong?
seeing.
No, it's working fine for me,
It's
Mark.
working okay, Mark.
Is it really only me? Never mind. I'm sorry.
Okay, so I'll move on. IPCC is the intergovernmental panel on climate change, and they have reports every year or every several years. And in each report, there are a lot of figures. And for these figures, actually, it's not very easy for the public to understand. So we want to improve these figures, but we face some challenges because if we want to improve these figures, we need the source code and data to reproduce these figures so that they can be SVG based, not the pixel based one. And we focus on this one specific report. And for this report, actually, IPCC provides a repository on GitHub, and they have some descriptions like the right parts However, we face a lot of challenges like lack of data, very difficult to set up environment, and sometimes we are very difficult to find the real README file. So we want to create reproducible figures from IPCC data, both for us and for the future researchers to do researches based on these sources. And we do several steps. The first step is set up the environment. We focus on Python file now, and we also preserve the original repository, and we use the submodel to preserve the original one. And for users, what you need to do is just run the download shell, and then the environment can be set. And the second one is prepare the data. The data is usually like from everywhere in the website. Like you will use a lot of time to find one. So now you just need to run the install.shell file, and then the data will be downloaded. And the third step is patch and run the code. Because some code they cannot just run, so we need to patch the code. And for users, you need to do is just run the run.shell file, and also we provide the README file for these all instructions, and we also provide instructions for future users, because these figures from 5-dimension input, running, output, quality, and post-process. You can see from the right part, if you see all green like the figure 4, so congratulations, this figure is exactly the same as the one in the report. But usually there are some orange or red stamps. You can see from this example, like the left one is the source figure, but the right one is the reproduced figures. It's not just one figure, there are several figures. And you need to do the rearrangement, and also like you can see from the legend one, the left one is not the same as the original one, and you also need to add some text, add some lines and find the missed subfigure to be the source figure. This is another example. The left one is the source figure, and the right one, you can see the color are not exactly the same, and also some very small details like the white for the lens, they are not the same. So we want to, in future, we also want to, we realize that the reproduced charts need post-processing, and we also face difficulty in ensuring the identical reproduction, and we also want to enhance the figures for border impacts. The right one, we also, based on the original repository, we also have a website, the GitHub repository for the reproduced figures, and if other people want to do this or use these resources, feel free to scan the QR code to see the repository. And also the left one is my homepage. I'm finding a postdoc. If you are interested in my work, feel free to email me. Thank you.
All right. Thank you very much. So do we have any questions for anyone in the group?
Hi, my question's for Fabio. I wondered if you could share a little more about your target users, particularly. I know you said this is participatory, but who have you potentially done user testing with, or who are your primary users?
That's a great question. So the workshop paper, they covers many research projects and tools. Some of these tools, they have been evaluated by climate experts through case studies and written by them, but also usage scenarios. But some of these tools, they have been used by community residents, though we did not have any evaluation in terms of user testing from the perspective of the community residents.
Can I ask a follow-up about that one? The community ones, particularly that you've had it with or experienced with, how are you finding? Are there any directions for things you're finding that they particularly resonate with, or that they maybe need more scaffolding with? I'm just curious about how it's going with the community members.
Yeah, so it has been quite different than engaging with experts as expected. Because once we attend these community meetings, they mostly rely on papers. So we have to port our visualizations to paper-based visualizations, and then they use these visualizations in order to engage other community residents, right? So there is this spectrum in the complexity of the visualizations that we create. And one of the challenges that we are currently facing is how can we support both the needs from the experts as well as the needs from the community residents without having to replicate effort, redevelop certain parts of the systems, right? So making sure that the visualizations that we create, the experiences that we create are flexible enough to account throughout this spectrum.
I'd have a question for Lou. So the lack of reproducibility you encountered in your work, was it more due to, let's say, unprecise documentation of the team that put the figures together, or was it due to changes in the software versions, for example?
We have encountered several issues that lead to a lack of reproducibility, including tools not being made publicly available, either through GitHub or other means, right? And that's due to the fact of the challenges of making open source code publicly available, right? Part of these tools, they are research projects that have their own constraints that lead to tools not being made publicly available. And one of the challenges that we are currently trying to tackle right now is how can we provide a cyber infrastructure that facilitates these tools to be made publicly available? How can we lower the barrier to the creation of open tools and open computing pipelines?
Thank you.
Michael, was that question to Lou, right?
Yeah, but
Lou, do you want to reply?
Yeah. But can you repeat the question again? I just forgot
so
the
I was wondering in your work with the IPCC figures, if you was it the problem to have found so few reproducible graphics in the selection? Was it due to the, let's say, not really completed documentation of the guys that developed the visualizations, or did it also have to do with, for example, new software versions that are not completely compatible or something like that?
I think the problem that the figures are not exactly same is because sometimes authors just upload the repository to the let's say managers, and then for some designers they will just update the figure like some detail thing, or actually they need to combine these figures all together to be a new figure. So they use another software to do these things, or sometimes they will update the elements to be like seems good, seems fantastic. Do I understand the questions right?
I think so. Benjamin?
Yes, that's a question also to Lou, General. I guess you have done a lot of work to create these figures and recreate the figures. I don't want to ask how long it took you to go through all of this and rewrite the code. On a high level, do you have any suggestions of what people who create those visualizations and platforms can do to help reproducibility, to make the life easier for people who want to scrutinize things?
I think that's a very good question. I think it's still a very long trip to do this, and I think the first step is a very detailed readme because because if you use Python, some libraries they will be outdated, they will change a lot. But if you say everything right and told the later future users that what version you used, and as a future user, I will be very easy to follow your work and find what happened to the Python library also with your code you write. So I think a very detailed README is very essential for reproducibility. And this is the thing that just came to my mind.
Can I follow up on this? Because I see we still have a bit of time in this session.
Okay.
Opening up the question to the other two talks, what would you think you can do in interactive systems to keep your systems reproducible or your findings, especially if you have lots of interactions happening, lots of exploratory analysis and these kind of things?
Yeah, I think that's a great question and a challenge because there are so many conflicting interests in terms of time to create these tools and time to engage with the experts, and reproducibility is perhaps the last of the concerns when thinking of building visualizations and tools and systems. And I think one way to increase reproducibility is facilitating, creating the technical framework to facilitate the creation of more reproducible tools and systems. And that's ongoing work by the community and many research groups.
I would like to
Amia,
add
do you?
yeah. So I guess reproducibility, interactive visualizations kind of helps solve the reproducibility issue because it's just the data that's probably changing. The interface remains the same, more or less. So anyone who tries to access the interface, the dashboard, they are bound to get the correct visualizations unless the data is not lying. So I guess interactivity in itself is one step towards making things reproducible, towards making research reproducible. So instead of just publishing plots for your paper, for your research, if you just provide them the link to the dashboard from where you created those visualizations, it's a good way of making sure reproducibility is ensured in the process. That's my thought. Yeah.
Thank you both. I think we're at the end of the session. Thank you, everyone. Thanks to the speakers. Thanks to those who discuss. Take the time to follow up with everyone after the session. Thanks again. And we're handing over to our last topic on people, art, and engagement. Over to you, Eleni.
Yes, hi everyone. So we are moving to session 4, people, art, and engagement. During this session, we have 4 presentations. 2 are of a long papers, and 2 of short papers. We're going to have presentations from Beth Altinger, Narges Mahar, Francesca Samsel, and Jessica Kendall-Barr. So let's start with Beth.
Hopefully that's working for everybody. So I'm going to walk you through the story of a project that we did with our students at Brown University, RISD, which is, for those who don't know, the Rhode Island School of Art and a very well-known arts institution, and Harvard University's Berkman Klein Center for Internet and Society. And I'll focus this presentation mostly on the process that we used to develop this partnership and the student collaboration. So we created a multi-institutional collaboration to expand public participation with scientific issues, to create maximally engaging visualizations, to bring local city data to life. And I'll talk a little bit more later about maximally engaging and what we mean by that. And to develop a coordinated course and research sprint across these institutions, we built upon expertise from a number of partners that you can see here, and then created an iterative exhibit of the student projects at Boston's Museum of Science, which is really cool. If you haven't been there, you should go. It's a great institution. And our paper listed here shares more about our process and lessons for others who want to do something like this. So I want to take a moment to just showcase our collaborators here. And I think pictures always tell the story a little bit better. So we can see these are students showing their work at the museum, and you can see that's quite a lively atmosphere. And so there were 5 different projects. One was about transportation and commuting options, and a game that people could play to understand the impacts of those. Another was an interactive sea level exploration of Boston's past, present, and future. And another explored and allowed people to suggest future historical and cultural landmarks, again, trying to get them engaged in how their city changes over time and giving them a sense of agency with that. Another was telling the story of the city through its trees. And finally, one about access and functionality of gathering spaces and how they relate to other spatial choices in the city. And this, I really want to emphasize how none of this would have been possible without the collaborative institutional framework, and that was a lot of work. So when we look at the lessons for others who want to do this, like at least the same amount of work that went into educational programming went into institutional partnership development. And each partner brought something different. So the Museum of Science provided a high trust public education access point where people are already coming to be inspired and to learn. And they brought their expertise in science communication. And one of the things we kept coming back to in the challenge of engaging the public is the 7-second rule. So apparently people only spend 7 seconds with an exhibit, and your challenge is to engage them so much in those 7 seconds that you earn, additional attention from them to get to a deeper and deeper message. The City of Boston provided access to their open data portal, as well as access to internal experts who worked on each of those data sets so that we could get a sense of the strengths and challenges and biases in those repositories. The MADE program, which I run, contributed both an entire studio course to this effort, as well as our students to continue on beyond the studio course. And then the Berkman Klein Center at Harvard added expertise in ethical data and technology use and more students from diverse fields across the school. And on the right side of this slide, the only thing that I would really emphasize is the commitment at both leadership and implementation levels was critical to the success of this program. So our educational program structure looked like this. So the project planning phase took probably the better part of an entire semester of the leadership team. And then phase 1 was inside a course that was focused on data communication, exploring the different data sets and visualization strategies, learning from curators and museum experts and other people who design for maximum public engagement, such as people who work in public broadcasting, for example. And then phase 2 had more expert input, and students started developing their visualizations and iterating on those. And then finally, for the exhibit itself, we had 2 exhibits. And so we did the first one, which we called a soft launch, and learned from the experience of engaging with the public. And that was surprising to see the students' growth. They knew that 7-second rule is real, but to experience it was very different, to see children try to understand what they were trying to communicate and really being exposed to the diversity of the public in interacting with their ideas. They improved a lot from the first exhibit to the second exhibit. And so some of the lessons learned from this is, there are many more in the paper, but I'll just emphasize that the public trust of museums is an interesting place to be developing these projects for and showcasing them. Public trust is declining in a lot of other areas of expertise, and I think there's an opportunity to work with museums in this way in particular. And getting outside of our institutional bubbles, our students anyway don't get a lot of feedback on their projects outside of other students in their institution or professors in their institution, which is not a very large sample. The second one is this high bar for engagement. 7 seconds is really ruthless, but I think worth learning about if we really are committed to getting to helping people understand these messages at a deeper level, and to be able to scaffold kind of 7 seconds, and what if you get 7 seconds more, and what if you get 7 seconds more, like what message are you trying to communicate in each of those kind of attention packages, if you will. And related to that, the importance of iterative design. So this coming year, we want to do another one that actually has a bit of a different theme, but we will add another iterative cycle because that was so valuable here. And then the last point is how valuable it was for our students to design within the messiness of local systems. So they had to work with, real world data, very complicated stories behind that data, and having access to people who worked on that data was really critical because there are things that you couldn't see in the data itself. And having access and connections to diverse experts and seeing alternative career pathways was really valuable to our students and actually influenced some of their choices after graduation. So I'll leave my contact information here. Thank you so much for listening. I'll stop there. Thank you.
Thank you so much, Beth. Excellent presentation. Narges, you're next.
Do you see it? Perfect. So I am Narges Mahyar, and I'm very excited to be with you all today. Thank you for organizing such a timely and important workshop. And I'm happy to talk about harnessing visualization for climate action and sustainable future. In this paper, I propose 5 considerations for enhancing community engagement and collective action regarding to climate change. And these are grounded both in prior work as well as my past 10 years of work designing visualization for community engagement. Due to lack of time, I will focus on presenting a few of them. So first, I bring the importance of inclusive and accessible visualization for enhancing climate education. And by inclusive and accessible visualization, I mean those visualization representation of data that are designed to be easily understood and navigated by a diverse audience, including those coming from marginalized group. And I'll talk about examples of simple and understandable visualization like infographics and pictographs that we use in our project for public engagement and showed massive success in terms of engaging diverse audience, which triggered our curiosity in examining this impact of pictograph in a more scientific experiments. So we ran a series of experiments, and the result was pictographs not only do not hinder understanding of visualization, but also enhance the basically relevance to the topic. And then the next point is about interactive visualization for fostering agency and deepening engagement with climate change so people can explore the data themselves, understand its implication, and engage more deeply with climate change data. For instance, in this project, we built UD Quiz Spaces, which is a multi-display, tabletop-centered project for environment for engaging the public in the very complex matter of sustainable urban design. And the simple and natural interaction with the tabletop, everything being touch input, and all of the real-time visualization fostered collaboration and co-creation among stakeholders and enable a wide range of public to be engaged with this tabletop-centered tools. Next, I'll talk about how in situ visualizations are important for bringing the matters to the public in a more relevant way and basically reducing spatial indirection. For example, in Rising Emotions, we combine data physicalization and art installation to show the public feelings about a sea level rise in East Boston. By embedding the flood level, basically projected flood level in future in this art installation, we made the threat of rising sea levels more tangible, fostering greater awareness and engagement within the local community. And I also talk about the importance of shared immersive experiences for catalyzing collective action. This is another example from our project where we had a communal extended reality bus tour, where we took the resident of Roosevelt Island in this bus tours to show them the impact of climate change on their own very neighborhood. And this kind of shared immersive experience transformed abstract climate data into something real, sparking creative solution and collective action. And with that, I'm going to thank you for listening to my talk, and let's turn data into a force for climate action together.
Thank you, Nargis. Great presentation. Next is Francesca's presentation. Ben, you're going to run the video.
Artists, data, and climate change. Distilled messages, multiple entry points, and layered metaphor. I'm here to talk about scalable climate communication, about finding a means of reaching large audiences within their course of their everyday lives, able to bypass our human defensive responses to threats too large to contemplate. Art is a language societies have used throughout time to enable entry into fundamental threats to life. Artists around the globe have turned their attention to employing artistic language to create multiple entry points into the reality of our changing planet, a topic whose consequences overwhelm our human ability to absorb and contemplate. Artists look for a distilled analogy that will prompt internal thought without triggering the overwhelm. Artists present pathways that lead the audience into internal discussions and thus construction of their own conclusions. Here we present climate-focused artists whose work reaches hundreds of thousands of viewers. Our question is, what are the common properties that have enabled these artists to speak to wide audiences around the world? We distilled the common threads down to 5 principles. Constrained by time, rather than explaining, I'm going to demonstrate via the work of Andrea Poli and B.D. Wolf. Andrea Poli's Particle Falls distills the impacts of human activity on the environment. It is an installation that uses particle monitors and large-scale projectors to reveal changes in the levels of particulate matter in the air at its location in real time. The project references a waterfall that changes in velocity and characteristic based on the amount and type of particulate matter in the air at that moment. When a plane flies overhead, one can see the increases in particulate matter generated by the plane. The same is true when a bus passes by. This demonstration negates the need to try and explain or convince anyone of human activity's impact on air quality. B.D. Wolf started as a musician, but turned to creating multimodal experiences. Her work, Red to Green, was a response to Al Gore's Inconvenient Truth so many years ago. She put it on a shelf, thinking that society would surely rise to the occasion. The core is a basic analogy on how the Earth is turning from green and verdant to hot and dangerous. However, B.D. was keenly aware that space, metaphorically and physically, needed to be built to provide audiences with context and time to absorb and contemplate. BD identifies 3 elements needed to create meaningful experiences that speak to our humanity and can be absorbed into our consciousness: multimodal ceremony, immersion or interaction, and story. She has gone on to build several very diverse exhibits built on these principles that are attracting worldwide audiences. I will leave you with our analysis and links to the sites of these artists discussed in the paper.
Forgive us, my dear, can't you see? It's the truth that we don't want to know, don't want to know, don't want to know.
Great. Thank you so much, Francesca and Ben, for running the video on behalf of Francesca. And now we have our last presentation from Jessica Kendall-Barr.
So good morning, everyone. My name is Jessica Kendall-Barr, and I'm a postdoc at Scripps Institution of Oceanography. I'm excited to share some of the projects that our team has been working on over the past 2 years. And I'm glad that folks from NASA's Scientific Visualization Studio are here with us today. This is some data from them that I used as a backdrop for some of the visualizations of Argo floats, oceanographic data. And I think that this ties in well to what I think is a common interest with everyone here today, which is how we can leverage some of the common systems and data structures that each person has been developing independently to improve all of our visualizations across projects. So EcoVis is this collaborative initiative to co-design multimodal environmental data visualizations. These visualizations are combining web browsers and game engines to show the benefit of informed management and nature-based solutions. Our 3 use cases show the flood protection benefits of coral reefs and mangroves, underwater behavior in marine animals, and simulations of controlled burns. Our working group met weekly for 2 years to share our successes as well as our frustrations, to code together and to provide feedback on the infrastructure and the design of each of these projects. And the projects that we're working on combine scientific, cinematic, and information visualization. So first, the project that I led is called Life in the Deep, where we're using visualization to better understand the impacts of climate change on marine life. And it's all built off of tools that I built for my dissertation to visualize the sleep patterns of northern elephant seals. So for that project, I used After Effects and Autodesk Maya. And since then, I've translated those tools to a lot of other study systems and species. So now those are allowing us to listen to the 2 beat per minute heart rate of a blue whale, to visualize foraging efficiency of whales that create bubble nets to feed. And it's also allowing us to visualize collective behavior for whole populations or groups of animals behaving together to interact with their environment. And those visualization tools can also be used to show the impact of a human-caused disturbance, like the sound of a ship. And these visualizations have been presented to some decision-making bodies at both the national and international levels. We've also done animations using After Effects to communicate indigenous knowledge and place-based knowledge about abalones and otters in Alaska. And this visualization on the Argo data that I showed earlier has been presented at COP at a climate change conference. But looking to the future, I can't be making all of these visualizations myself in After Effects. So this project and this initiative are really about how do we scale that? How do we get data more quickly into web browsers, into game engines, so that people can generate these types of visualizations on their own without losing some of the power of a narrated animation or story. So for 5 years now, I've been working with the Coastal Resilience Lab at UC Santa Cruz.
To advance solutions and our understanding of risk with rigorous hydrodynamic and
you can listen to the sound later if you want. And so that work is focused on visualizing the flood protection benefits of coral reefs and mangroves. And those ecosystems not only support marine biodiversity, but they also provide really critical flood protection for coastal communities. So these visualizations that were put together by Ian, who's joining us today, take 2D outputs from Sphinx and XBeach and layer those with OpenStreetMaps data and bring those into web browsers like web browsers and Unreal Engine. We can use those scenes to then communicate with community members, such as this ambassador from Belize, or to decision makers at the federal level like FEMA and the Army Corps of Engineers. And then we've also been using immersive tools and web browsers to visualize wildfire resilience. So as a postdoc, I've started to work with Wi-Fire, which is this group at UC San Diego that's led by Ilkay Altintas to improve wildfire resilience through physics-based simulations of controlled burns. And the visualizations that team has been working on show how controlled fires can reduce vegetation buildup and then mitigate the risk of megafires. So for that project, we're displaying physics-based fire simulations generated using fast fuels and quick fire models, and combining those with LiDAR scans that are actually taken on the forest floor so that fire practitioners can actually visit the forest that they would otherwise have to drive to and get a sense of the vegetation, the thickness of the trees, and the overall risk for wildfire in that area. And those tools have been demonstrated to land management agencies, including the USDA Forest Service, as well as several cultural burning organizations. And they were recently featured in this hands-on demo for the House and Senate AI caucuses on Capitol Hill. So some lessons learned from our work together. Audience is very important to consider when you're talking about domain experts versus policymakers. Policymakers generally favored a really clear narrative and a clear takeaway, while the domain experts and fire practitioners wanted to get into VR and look underneath tree trunks and around tree trunks and really get into the nitty-gritty. And then reproducibility was super challenging for us, even with using version control tools like Perforce and GitHub. The reproducibility of some of these bespoke pipelines poses a lot of challenges when you're talking about sharing massive Unreal projects or massive tech stacks that are hard to translate from one project to another. More than ever, it's really important that we communicate at least what data structures we are using. And ideally, we start to use some of the same data structures so that we can just bring people's data into our shared visualization playground. And I think that that's been a huge benefit of having a working group like this, where we can sort of translate lessons from each other. Flexibility is really important. We ended up switching the tools that we use several times. So I think just not marrying yourself to a specific tool and instead just prioritizing the data and the narrative that you're bringing forth. And then videos, even though immersive tools can be really exciting, never underestimate the power of a video that can be shown really widely in PowerPoints to key decision makers and stakeholders. And then also, I always tell the engineers that I work with that I'm always pulling up stuff on my phone to show people. So having something that's available quickly through the web browser is also really important for demonstrations. So you can visit our EcoViz website to see some of these examples. Something that's cool is that this website is powered using a Notion database that is dumb enough that even I can understand how to put in new entries and modify the descriptions of each of the videos. So that's something for you to check out. And feel free to reach out if you're interested or want to get involved. We're always happy to have more people involved.
Wonderful. Thank you so much, Jessica, for your presentation. Everyone, this concludes the 4 presentations for this session, for this topic. Please feel free to either raise your hand or post questions on the chat or Slido. I'm not sure. Let me check if there are any hands up right now for questions. Maybe till more questions come, I can jump in. So from seeing all the presentations here, all the projects, all the efforts, this is a collection of, let's say, projects that are interdisciplinary, multidisciplinary, and also have another key component, which is collaboration. These words, these keywords are often used, I would say lightly, but these are very challenging efforts, right? And even, let's say, the projects within that are visualization driven, I would say that draw from either InfoVis or cinematic vis or even many different types of data visualization. So there is a lot of research in these fields, but on my end as a practitioner also, and sometimes, we have to work as a practitioner, have to move forward with some instincts, right? Especially when I am I'm going to traverse a field that I have not traversed before, or there is no research there. I would like to ask you if there were any unexpected findings or outliers from your projects, something that you didn't expect that either turned positive or negative.
So, as a visual artist, I was very surprised to find two things. One, the music is critical for the I mean, I know that sounds weird, especially to this crew, but so B.D. Wolf worked with Oliver Sacks, and Oliver Sacks talks about music and gardening as being like the roots into our soul, and one of the concepts that we work on is that you have to speak to someone intellectually as well as emotionally, or else it is not absorbed. That's research been around a long time. So I was surprised to see and understand the impacts of music when it's incorporated into presentations. And then the other piece that I wanted to mention was the 7-second rule. It's huge. And I've done a lot of museum exhibits and that kind of thing. But so when we looked at a whole kind of rubric of artists and whatnot. And that's how we distilled to those principles. The interaction and the connection to the now. So as soon as we gave someone a puzzle to solve, the 7-second rule ran out the window. And so I think that this is an important piece to understand, is that involving audiences in the exploration and putting them in the scientist's shoes as in the exploration, as opposed to just communicating fact, is a key means of moving beyond the 7-second rule.
Yeah, I think I would add to that. So I don't mean to imply that the 7-second rule is the end, but even to get them involved in a puzzle, those are your first 7 seconds, right? To get them excited about the puzzle. And then you can have more and more time with them.
Yeah. I worked with a team from the Smithsonian, Smithsonian for like 20 years. And we did a lot of testing, and we had exhibits where people were standing for 5 and 6 minutes, and she was like stunned. So having a museum professional that understands how to move through those stages was critical.
Yeah, I totally agree.
Thank you all. I think unless someone else from the presenters wants to jump in, we have questions. Amia has a question, and then Rachel.
Yeah, I had a question, but I think Francisca and Beth just addressed it in the discussion right now, so I'm good. I just wanted to know what it entails to catch the viewer's attention beyond the 7-second rule, and how much information can you convey in that 7 seconds? So first, you have to catch the attention of the viewer, so that you can do it through probably touching the sentiments of the viewer, probably getting them hooked into the idea, and then maybe delivering the facts so that they can actually process those facts and understand the picture. So I guess that was good insight from both of you. So thank you so much for that.
I would really suggest consulting kind of professional literature and professionals because it's like that, but they do know what they're doing.
Yeah, and I would just add to that user testing. So I think what's so hard, and our students went through this, is they want to communicate everything. And we can tell ourselves a story that by putting it out there, that's somehow the equivalent to that information being digested.
Yeah.
But actually researching how much is getting digested with each iteration is really valuable, and researching that with people who are, not also on the project, of course.
Yeah, I think I would add to that that that's my experience too. The scientists, understandably, they want to get everything out there. But one of the things that I went to art school, one of the things that we're trained to do is a distillation, and that's key. What is the one fact that is going to bypass our assumptions, is going to grab our curiosity, and is going to want us to learn more? For instance, there's a Vanessa Benza's piece is about plankton, and she opens with 1 out of every 4 breaths we take is generated by plankton. And so that's the notion, is distilling. You don't need to tell it. What is the message and how do you grab someone quickly?
And I'll also add that I teach a data-driven animation course where we give the students only 2 minutes to tell their story. And they always make it longer than 2 minutes, but at least it's usually not longer than 3 minutes. And we have them pick music really carefully and develop a hook for the first 7 seconds. And somebody mentioned Pixar. We use some of Pixar's tricks of pairing the extraordinary with ordinary, like, the concept of The Incredibles, or, opening with what if there was a world where, and just like tapping into awe and imagination about how we could build a better future.
Thank you all. Amy, you want to jump
You're
in?
muted, Amy.
Thank you. Amy Allen, I'm the one at Pixar. I'm new to the data viz world, but I was wondering, especially with engagement, and Jessica, you touched a little bit on it with the policy makers, but what do you find has been the most effective to engage policymakers in making decisions, especially when, especially in the political world, they may be thinking more about the day-to-day cost of people's living and everything like that?
So I can start. I think that when scientists talk about engagement and community engagement, we're typically talking about public and community events and how we engage the public in that way. But if we're talking about stakeholder and decision maker engagement, I think that the techniques are different, but there are some shared values between public and decision makers. So one example is that so I work with this PI at UC Santa Cruz, Mike Beck, who spends a lot of his time in conversations with FEMA and with the Army Corps, who are looking at these numerical calculations of benefit versus cost. And they're looking for a good financial scenario. But what's going to be most effective and easiest to convince their constituents and their fellow policymakers of is something that also looks good and feels hopeful. So Ian has been developing these photorealistic scenes where we can actually see a hybrid coral reef scenario and have somebody feel better about that solution compared to just the seawall that's a concrete structure. And so I think there's some overlap there where we can tap into our underlying humanity and help reach people even next to a benefit cost analysis that's showing that it's in the green. We can show that the solution is also green.
I would just add that there are 2 kinds of policy levels. That's decision makers, and they need like facts, and then there's the next level, like if you're sending something to Congress or to be passed around in Congress. And so they need something really short. But the thing that I've found is how little just basic knowledge about climate change is. It's really astounding. And so again, it goes to the point of, rather than trying to show them specific exact details, just some basic underlying facts that can be communicated clearly and easily and understand the overall is what we found.
Thank you all. I know we're running a little bit over time, but let's maybe take one more question. I know Rachel had raised her hand, and we can take the rest in the open discussion. If Narges and Fanny, that's okay with you? Okay, Rachel, go ahead.
I just want to add to what Jessica said earlier. We also have found that the end of our narratives we sort of dial back the sea level rise and the wildfire and that, and we have that sort of hopeful ending as well, because we think that's also really important to leave people with that sense of agency, opportunity, so it is, I'm going to add to that. My question was for Beth, and it was about this sort of, like we've been talking about, the hook and the 7 seconds, and then this more spectrum of engagement. You want to sort of bring people along. I was just curious, have you embedded your experiences in any public programming, or is in the future, are you thinking about having some sort of more dedicated programming around it? So there's sort of longer experiences you're going to have people engage in this with, or is it catching them on the floor through the exhibit primarily?
Yeah, last year was the first year that we have done this, and it was wonderful. And so we're doing another this year, and we've actually been given more floor space for it, which is really exciting. And I just think this makes so much sense, and I would love to collaborate with others on it. I mean, that's kind of in the DNA of our program, and it makes sense. It's a heavy lift, and so I tried to emphasize that in the talk too. The partnership level of these and the amount that everybody involved has to personally care about it is pretty high. And so I like to look for those people and find a way to, connect our students across institutions, connect them on a similar project. I think ultimately there could even be like maybe even with NASA, like an annual challenge or something like that students from a lot of different universities, perhaps faculty as well, could be responding to something, just to not have it be every program is doing it for on their own. So that may be an indirect answer. We definitely plan to do it again, but we do need some efficiency on the institutional lift side of that. I also think it would be pretty cool. So we might work with UCSD this year, and I think it could be cool to have thematic data competitions, because that's fun for students, but that are showcasing how climate is going to affect different ecosystems differently. So something maybe ocean-centered that is in New England and in San Diego and in Rio, and students from these different institutions are working on a similar design brief, but the outcome is different because the locations and their challenges are different. So I guess my answer is just an invitation to look for ways that we could collaborate, because each of those pieces is such a heavy lift.
I fully understand. Thank you, Beth. Great discussion. I think it's time though to move to the last part of this workshop. We are going to have kind of like a summary and an open discussion. So please bring your questions, wishes, invitations there too. Ben, would you like to lead?
Thanks, Eleni. And again, thanks for everyone in the workshop.